Hello everyone, this video will talk about another question relates integrated rate law, and let's see what else it's about. Okay, so the question is giving us a balance equation and then it telling us such info. So it's a plot of 1 over the concentration of the reactant versus time is linear and the slope is equals to this value. Okay, and then basically it didn't tell us what's the reaction order, but there are many hints actually telling us what's the reaction order. One could be the slope, right, having this value and have certain units. Okay, and then it's also telling us which term will have this linear relationship. Okay, so now based on what we have learned, we know, okay, this, right? Let's try to a plot. Let's do this plot. Okay, so this is the plot, and then the x-axis is time, and y is 1 over the concentration of the reactant, and the slope is positive slope, and so let's try to draw that. Okay, and the slope is 0.056 molar per molar per second. Okay, so there you go. This, I think I know what's this relationship, right? Okay, this is typical second order reaction. We know the reaction itself, the linear form of this reaction equals 1 over concentration equals kT plus 1 over the initial concentration. Okay, so again, this shows that the linear relationship, oh, now you know, oh, the slope is K. Also, right, the units was giving us the hint. Okay, so this is the unique unit for the rate constant for second order reaction. Right? Okay, so that's the unit. Okay, for K for second order. Okay, so now that's it. And of course, once we work on second order reaction, we also should, right, since we are looking at it, we should remind ourselves, what else I'm supposed to know? As I said, we should also know the half-life. Okay, half-life for second order is what? The half-life of second order equals to 1 over K times initial concentration. What else we should know about second order? The rate law, right? Rate law equals to K rate constant times the initial concentration squared. Of course, from here you can also derive what's the unit. Let's just review all the information. Unit for rate constant, K, that should be molar per molar per second. All of this as background info. Once you figure out about second order, we should remind ourselves, okay, I know all of this information. This was needed for this, apparently for this question, right? The unit for K was needed. Knowing the linear relationship for second order reaction equation is needed. So then that's all helping us figure out the second order. And now let's see, it's telling us the initial concentration and it's asking us how long will it take 1/2 of the reactant to react. Okay, half. So basically, that's half of it falls into the original concentration. You go. That sounds familiar. That sounds like half-life definition. Okay, so now that's all we needed to solve the question. That's easy now, right? Okay, so we just plug it in. So half-life, that's what we're looking for. It didn't say half-life. It described it for us. How long will it take 1/2 the concentration to react? Well, half the reactant to react. Basically, we react half, we have half left, right? That's the concentration falls into half. That's the definition for half-life. Okay, now let's just do that 1 over K multiply initial concentration, even though the description sounds hard once you see through what it's trying to tell you. Now the question becomes very easy. So K is already given 0.056 per mole per second. Multiply initial concentration 0.80 molar. It all cancels out. After I calculate, the unit will come out as a second. Of course, put this into your calculator. Nice and easy. 22 seconds. Okay, so that's it. Okay, so another question seems complicated. After all, it's actually a very easy question. Because we know what's going on, we know our basics, and that's it. And thank you for listening.